10 minutes per domain, 50 domains. That's 8 hours of manual work. And that's assuming nothing goes wrong. Auth codes expire, confirmation emails land in the spam folder, unlock steps get skipped, and you're tracking everything in a spreadsheet with zero retry logic and no audit trail. The fix isn't faster clicking. Every single step of the domain transfer lifecycle maps directly to an API call. In this video, I'll walk through a complete implementation using the Name.com API. We'll cover HTTP Basic Auth setup, auth code retrieval, transfer initiation, status polling with Exponential Backoff, and a full bulk migration script you can run against a list of domains today. Let's get into it. Before we write a single line of code, let's cover what you'll need. You need a Name.com account with at least one domain registered. We'll use that domain to test the auth code and transfer endpoints. On the tooling side, you need curl in your terminal and Python 3 with the request library installed. If you don't have requests yet, just run pip install requests. We'll also use the Name.com Sandbox environment for safe testing. The base URL is api.dev.name.com. For production calls, it's just api.name.com. I'll call out which one we're hitting at each step. Now let's go grab an API token. I'm on the Name.com API settings page. I'll click Generate New Token, give it a descriptive name. I'll call mine domain-migration-script and copy the token that was generated. This is self-service, no approval queue, no sales call. Now let's immediately verify the token works. I'll drop into the terminal and run a curl command against the domain's endpoint. I'm using the -u flag, which takes my username and API token separated by a colon, and base64 encodes them into the authorization header automatically. If I get back a JSON list of my domains, auth is working correctly, and there it is, a 200 response with my domain list. Setup is confirmed, and we're ready to move on. Now let's talk about the domain transfer lifecycle, because understanding the state machine will make the polling logic we write later much clearer. A transfer moves through a fixed sequence of states. After we post to the transfer's endpoint, it enters a pending transfer state. Some registrars require explicit approval, which moves it to pending approval. Once approved, either manually or automatically after the icon window, the transfer reaches the complete state. At any point in the first 5 days, we can cancel, and if the auth code is wrong or the domain is still locked, the transfer lands in a failed state immediately. There are also 4 preconditions to validate before initiating anything. The domain must be unlocked, whose privacy must be disabled on TLDs that require it. The domain must be more than 60 days old since registration or last transfer per icon policy, and DNS records should be backed up since they don't transfer with the domain. Let's retrieve an authorization code. This is the first real API call in the transfer workflow, and there's an important timing detail to keep in mind. Retrieve auth codes immediately before initiating each transfer, not as a pre-batch step, hours earlier. For most TLDs, codes are valid for up to 7 days. The endpoint is get/domains/your-domain-name:"get auth code. I'll run it now against a domain I own. The response is a single JSON field, auth code, with the code as a string. In Python, you can wrap this in a getAuthCode function that takes a session object and a domain name as parameters, calls raise_for_status to surface any HTTP errors immediately, and returns the code directly from the JSON response. I'm also building a JSON file, keyed by domain name to store codes as I retrieve them. Now let's initiate a transfer. The endpoint is post/transfers, and the request body requires 2 fields, domain name and auth code. I can also pass privacy enabled as true if I want who is privacy enabled on the gaining registrar. Here's the curl command. I'm passing the JSON body with the -- data flag and setting the content -type header to application/JSON. A successful response comes back as HTTP 200 with the transfer object. I want to pay close attention to that status field. It should read pending_transfer if everything went through correctly. There are two main error responses to handle explicitly. A 409 conflict means the domain is already in a transfer, and I can't initiate another one. And a 400 bad request means I'm missing a required field in the request body. In Python, the initiate transfer function wraps this post call, returns the response data on success, and raises a runtime error with the full error body on failure. That full error body is critical for debugging later in the bulk loop. With a transfer in flight, we need to poll for status. The total transfer window is up to 7 days, so the polling loop has to be patient. The endpoint is get/transfers. I'm checking the transfers.status field on each response. If it's completed, I return immediately. If it's canceled or failed, those are terminal states. Log the reason for the failed transfer and try to resolve it before attempting another transfer for that domain. If I hit pending, I flag it for manual review, because expediting that step requires action in the registrar dashboard, not another API call. The normal in-progress state is pending_transfer. If the polling loop runs past 7 days without reaching a terminal state, I raise a timeout error. One important note: for production systems, webhooks are a better fit than a long-lived polling process. The Name.com API also supports webhooks that fire on state changes, so you can react immediately without keeping a script running for days. Let's quickly cover cancellation, because you'll need it when an auth code is wrong and you need to restart. The endpoint is post/transfers/your domain name :cancel. Cancellation is only possible within the first 5 days of a transfer. After that, the window closes. Here's the curl command. There's no request body needed. If you hit a failed status in the polling loop and the cause was a stale auth code, the workflow is: cancel the transfer, retrieve a fresh auth code, and reinitiate. Now let's put everything together in the bulk migration script. Here's the complete bulk migration script. It reads from a CSV with 2 columns, domain and auth_code. If auth_code is blank, the script retrieves it from the API automatically. At the top of the loop, there's an idempotency check. If a domain already has a transfer logged in the output CSV, it skips initiation entirely. This is the key to making the script safe to rerun. If the script fails at domain 23 of 50, I just rerun it. The first 22 are already logged and skipped, and it picks up exactly where it left off. I'm processing domains sequentially with a 2-second sleep between requests. The audit log captures domain, transfer ID, timestamp, and status per row, appended on each pass. Let's recap what we built. We set up HTTP Basic Auth with the Name.com API using a session object in Python. We retrieved auth codes programmatically with the right timing strategy to avoid expiry issues. We initiated transfers via post, handled the 2 main error codes, and built a polling loop with Exponential Backoff that covers all transfer states through to completion. And we wired it all into a bulk migration script with idempotency, structured error handling, and a full audit log. The same Name.com API spec covers domain search, registration, DNS management, and renewals. So the auth and request patterns you've seen here apply across the entire platform. The full article with all the code from this video is linked in the description, along with the Name.com API docs, and a link to generate your token right now. If you found this useful, subscribe for more tutorials like this one. We cover developer tooling, API integrations, and platform engineering workflows every week.